Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining broadcast domains. In the previous video of this series, we talked about collision domains, the network infrastructure within which two or more Ethernet hosts may simultaneously attempt to communicate, resulting in a collision. We also saw how switches, when deployed correctly, eliminate the possibility of collisions, resulting in a more efficient network. There is another concept that is similar but larger in scope that we must also understand to get a good grasp of layer 2 networks, and that's the broadcast domain. A broadcast domain is the network infrastructure within which a layer 3 broadcast, also known as an IP broadcast, will be heard. In other words, if I have a PC that sends an IP packet with the subnet's broadcast address as the destination, the broadcast domain consists of all the devices that will receive that packet. Now, typically, a broadcast domain aligns with several other networking constructs as well: network segments, VLANs, and IP subnets. A network segment is typically a portion of a network where all devices share the same layer 2 communication space. In early days of networking, this was literally a physical segment, like a shared Ethernet cable or a hub where every device could hear every other device. Today, with switches, this concept becomes more logical rather than physical. A VLAN, or a virtual local area network, is how we logically define a broadcast domain in modern switched networks. When you place devices into the same VLAN, you are essentially saying these devices belong to the same broadcast domain. Practically speaking, any broadcast frame, such as an ARP request or a DHCP discovery message, will be flooded to all ports that are members of that VLAN. We'll talk more about VLANs in a later video, so stay tuned for that. Finally, broadcast domains typically align with IP subnets as well. They usually map one-to-one with a broadcast domain. All devices in the same subnet share the same network address, the same subnet mask, and the same broadcast address. This design makes sense because IP relies on broadcasts for certain essential operations, like address resolution and service discovery. Now, when we talk about broadcast domains in the context of layer 2 switching, what we're really talking about is which devices can hear each other's broadcasts and which ones cannot. Switches forward broadcasts within a VLAN, but they do not forward them between VLANs. That boundary is where a router or a layer 3 device comes into play. So if this host here sends a broadcast, it will go to these devices, but it won't go beyond this router here. This is because the boundary of a broadcast domain, by definition, is the layer 3 device that performs routing for the corresponding subnet. Typically, you will have one router present within each network segment or broadcast domain, which acts as the default gateway to allow hosts in that network segment to reach destinations outside of that network segment. Now, when it comes to network design, the idea of the broadcast domain is very important. One of the key principles in good network design is to keep broadcast domains small. Why? Because every broadcast is processed by every device in that domain. As the number of devices grow, so does the amount of broadcast traffic, and that can start to impact performance. Smaller broadcast domains mean less unnecessary traffic, and thus better efficiency and more predictable behavior. Smaller broadcast domains are also much more manageable. Troubleshooting becomes easier because problems are isolated. If there's a misconfigured device, a broadcast storm, or a layer 2 looping issue, it only affects a limited portion of the network, that specific broadcast domain, rather than the whole network. This kind of segmentation makes life much easier for network administrators. Security is another big reason we care about broadcast domains. Devices in the same broadcast domain can see each other's broadcasts, including things like ARP requests and DHCP messages. By separating devices into different segments, and therefore different broadcast domains, you reduce unnecessary visibility between systems. And this is especially useful for systems which are more sensitive in nature, like servers that run sensitive services on your network. This helps with containment, it limits lateral movement, and it also enforces a logical separation between departments' roles or even trust levels. Now, it's also worth briefly comparing IPv4 and IPv6 in this context. IPv4 relies heavily on broadcasts for things like ARP and DHCP discovery. This makes broadcast domain design especially important for IPv4 networks. But IPv6, on the other hand, eliminates traditional broadcasts and replaces them with directed multicast and neighbor discovery mechanisms. While this reduces some of the broadcast-related noise on the network, the concept of logical segmentation is still just as important for IPv6. You still want controlled layer 2 domains with clear boundaries and good traffic isolation. So overall, broadcast domains are not just a technical detail. They're a design tool. They help us control scale and improve performance. They simplify management, and they also strengthen security. Now, we can create broadcast domains by physically placing routers at specific points in the network, and by isolating switches into separate physical areas. However, this approach can quickly become cumbersome and often very expensive, because it tightly couples our network design to the physical layout of devices and their cabling. Any change in the requirements might mean moving hardware, adding new devices, or recabling parts of the network. This is where VLANs, or virtual local area networks, come in. VLANs allow us to create broadcast domains in a far more granular and controlled way. Instead of relying on physical separation, we can take a single physical infrastructure and logically segment it into multiple independent network segments. Each of these segments becomes its own broadcast domain, even though multiple VLANs may share the same physical switches and cabling. VLANs give us much greater flexibility, better scalability, and more precise control over how devices are grouped and isolated. And in the next video, we'll dive deeper into how VLANs work and how they make this kind of logical segmentation of broadcast domains possible. Well, that's it for broadcast domains. For now, I'd just like to say that if you made it this far, thank you. And that tells me that you really care about understanding this stuff, and I appreciate it. If you want to go deeper, I've recently launched my website at telecomTech.io, where I'm building full courses with labs, quizzes, and real-world configurations. There aren't many courses there yet, but many more are on the way. Check it out, subscribe to the newsletter, and you'll get early access and better deals on future releases. I'm Lazarus at telecomTech. I hope this has been helpful for you, and I'd like to thank you for watching.